Welcome to The Explainer. So today we're jumping into this really radical idea from a new physics paper, and it's a big one. What if the universe isn't made of things at all, but just rules? Yeah, it's a concept that could completely flip our entire understanding of reality on its head.
Okay, so let's get right to the heart of it. The whole argument in this paper is that a single fundamental error has been compounding for over a century and a half, an error that's been holding physics back from its ultimate prize, a unified theory of everything.
And we're not talking about a simple math mistake here. No, this is about a deep, profound misunderstanding that's just gotten more and more tangled over time. The paper claims we've been fundamentally confused about what the universe is even made of.
So, to really get what they're claiming, we have to start at the scene of the crime, We need to look at the central conflict that sits right at the very heart of modern physics.
Okay, so on one hand, you've got general relativity. It paints a picture of a universe that's smooth, continuous, kind of like a ramp. But then you have quantum mechanics, our theory of the very small, and it describes a world that's all jumpy and pixelated. It comes in these discrete little packets or quanta, more like a staircase.
Look, they just can't both be right, at least not as they are now. And this isn't some tiny little detail we can just sweep under the rug. No, this is the biggest unsolved mystery in all of science. It's like this giant flashing red light screaming at us that something is deeply, deeply wrong with our most basic assumptions about how reality works.
All right, so to understand the fix that this paper is proposing, we actually have to become detectives and go back in time. We've got to trace the clues of what it calls a single compounding error all the way back to where it started.
So the paper points to 3 key moments where we took a brilliant step forward, but also kind of a step in the wrong direction. First up, Maxwell. He saw the structure of fields, but he imagined them as some kind of mechanical substance. Then Einstein comes along and brilliantly gets rid of the substance, replacing it with pure geometry, the curvature of spacetime, an amazing leap. But the paper argues he stopped one step short. And finally, you get the pioneers of quantum mechanics. They figure out that nature is quantized. It comes in whole numbers, but they basically just threw up their hands and declared it a brute fact without ever explaining why. So each of these incredible breakthroughs, while necessary, actually ended up digging the original hole a little bit deeper. And all of this brings us right to the core of this supposed mistake. We've been looking for the fundamental stuff, right? The little pieces on the chessboard of reality. But what this paper argues is that the universe isn't made of pieces at all. It's made of the rules that tell the pieces how to move. Okay, so what are these rules then? The solution proposed in the paper is all about correcting this fundamental category error by laying out a really clear hierarchy of how reality is actually structured.
The paper lays out this causal chain. Right at the very top, you have topology. Think of it as the ultimate rulebook. It sets the absolute laws for what shapes and connections are even possible in the first place. From those rules, geometry emerges, which is all about the cost or the energy it takes to make those shapes. And finally, you have dynamics, which is just how that cost plays out over time. But here's the absolutely crucial part. This is a one-way street. The arrow only runs from top to bottom. Topology is the boss, period.
So what exactly is topology? Well, here's a simple way to think about it. To a topologist, a coffee mug and a donut are the exact same thing. Now, why on earth would that be? It's because they both have exactly one hole. See, topology couldn't care less about curves or distances or how stretched out something is. It only cares about the really fundamental stuff, like how many holes something has and what's connected to what.
Okay, now this is where putting on these topology glasses gets really, really cool. It completely changes how we see the most fundamental things in the universe, like particles and fields. All right, so I want you to forget everything you think about empty flat space. This paper argues that the fundamental arena of the universe isn't a flat sheet. It's actually toric. In other words, it's shaped like a donut, and that shape is everything. Because it means you have 2 fundamentally different ways you can travel across its surface. You can go around the long way, or you can go through the hole. And this simple donut shape is where a huge, nagging paradox in physics just melts away. So look on the left. You see a path that loops around, and after a certain number of trips, meets back up with itself perfectly. The paper calls this a rational slice. And that, it claims, is what a particle is. It's a closed loop. Now look at the right.
That's an irrational slice. It's a path that never closes. It just goes on and on, eventually scribbling over the entire surface. And that's what a field is.
So just pause and think about that for a second. Particles and fields aren't two different kinds of stuff. They're just two different behaviors that can happen on this one single underlying donut shape. And that means the famous spooky wave-particle duality, well, it isn't a paradox at all. It's just a simple geometric question. Does the path on the torus close on itself, or doesn't it? Is it a stable, repeating pattern, a resonance, or is it just wandering?
This new model also gives us these really powerful new ways to think about the forces of nature. It sort of shifts our whole perspective from thinking about objects to thinking about something more like music.
The paper talks about this really fascinating idea it calls a Fourier turn. And the concept is this. You have a super complex, tangled up topological path, basically a knot in some higher dimensional space that we can't see. But that knot gets translated or transformed into something we can perceive, a specific frequency, just like a musical note. So in this picture, a particle is simply the note that we can hear being played by a knot that we can't see.
And this whole universe as music idea becomes incredibly powerful and predictive when we look at this weird phenomenon in music called the wolf tone. If you've ever played a cello, you might know it. It's this ugly, jarring, stuttering sound. And it happens when a note's frequency perfectly matches the natural resonant frequency of the instrument's wooden body. All the energy gets trapped in the instrument itself, and it can't get out to create a clean sound. Okay, now check this out. This is the amazing part. The paper makes the case that the weak nuclear force, one of the four fundamental forces of nature, behaves exactly like a cosmic wolf tone. The reason its particles are so massive and have such a short range is because their energy gets trapped and damped by the very structure of spacetime itself, just like that musical note gets trapped by the body of the cello. The force's strange, lopsided nature is basically the structural flaw in the instrument that's causing this cosmic bad note. Okay, so let's bring it all home. Let's see how this one single shift in perspective, from thinking about substance to thinking about topology, manages to resolve all those big paradoxes we started with. And just like that, the biggest head-scratchers in physics, they just kind of dissolve. Wave-particle duality? Solved. That's just the difference between a closed path and an open path on that torus. What about quantization? The weird fact that everything comes in whole numbers? Well, of course it does. That's the natural result of counting closed loops. And the biggest prize of all, the epic conflict between general relativity and quantum mechanics, they're not in conflict anymore. They're just two different, incomplete descriptions of the same deeper set of topological rules.
So the crucial takeaway here, the big idea, is this. For centuries, we've been hunting for the fundamental thing, the smallest possible bit of stuff. But maybe we should have been looking for the fundamental rule. The universe isn't a box of tiny billiard balls. It's a structure of rules, of constraints, that determines which patterns, which beautiful resonances are allowed to exist.
This single idea, if it's even close to being right, completely re-enchants the cosmos. It transforms our picture of reality from, a bunch of dead, inert objects bumping into each other, into a vast, resonant chamber of unbelievable complexity and beauty, all governed by the simple, elegant rules of shape and connection. And that leaves us with one final, and maybe slightly mind-bending question to chew on. If reality is just a set of rules, a game defined by topology, then who or what is playing the game? Thanks for joining this explainer.